So hello guys and welcome back to student coordinator at Marvel. So today we learn a little bit about what oscilloscope is. So oscilloscope is a device, as you can see, which will display okay, let me just give you a present. So you see this sine wave. Okay, you see in your home you get 220 volt AC voltage. How do you know it's AC voltage? How do you know it's not DC voltage? What makes AC voltage different from DC voltage? Well, if you look at the mathematical equations, it will tell you okay the phase varies and all the stuff like that. But then how do you see it in real life? If you want to see the variation of the wave, so how do engineers get to know okay there's something shorted here or something like that? So to do that, we use something known as oscilloscope. So this is a keyset oscilloscope which has an inbuilt function generator. So basically, I'm taking a sine wave. So as you might have seen in school curriculum, or let's say how a sine wave works. So what exactly is happening is the voltage here is increasing from, it's 5 volt peak to peak. So it's from positive 2.5 to negative 2.5. So that is what is happening here. So that is what you are seeing here. So there are a few options here. Let's say display. So and measure. Okay, let's say measure. So what I'm doing here is measuring the frequency. I'm measuring the frequency. If you can zoom in. In the peak to peak voltage that is 5.18 volts, and the frequency is 1 kilohertz. So basically, let's say, okay, so how do we do that? We use this probes. So this probe, what you see here, I connect with some components. Let's say that I have a clipper series, or okay, if you don't know clipper series, let's say I have an electric main itself. Do not do this. But if I were to plug this inside the electrical socket, I will get something around like this. But instead of 5 volts, I'll get 220 volts. And instead of 1 kilohertz, I get 50 hertz. So that's a norm in India. So 220 volts is 50 hertz. So the same way, this is not limited to just sine wave or some simple stuff like this. It can be done for many stuff. Okay, if you go for let's say okay, let me just lay this one thing of how complex oscilloscopes can be. From a simple sine wave which you just saw, it can also go up to play something along these lines. Okay, so the button is here is an auto set button. So this is one of the best oscilloscopes out there. So one of the advantages is auto set. So basically, when you have the history of oscilloscope, we have this is a DSO basically, digital storage oscilloscope. The original ones which were there when it was created was a cathode ray oscilloscope. So how cathode ray oscilloscope works is basically you have electron beam which gets deflected by the signal. Let's say I have a sine wave. This sine wave manipulates the electron beam. Let's say there's a magnet or something, and electrons have a negative charge, so they get attracted to the this magnetic field. They get affected by the magnetic field. So based on this affection, the x and y and then axis, you get the wave, sine wave. So that's how the old ones used to work. This is a digital storage oscilloscope, which means that it has chips inside which performs this function based on input and output. There's some ADCs and DACs and all stuff involved. Let's not go into that. Okay, coming to this, okay, you can see that I am playing a video here, which is same thing being played on this. So a small video which is here, it's not that clear because we are literally transmitting signals here. So that is the beauty of oscilloscope. That's the beauty of electronics as such. So you can visualize anything. Let's say you see how you have in math any equation, any curve or any diagram. Let's say your entire figure itself can be described using equations. Same way with the help of proper voltages and everything. Same thing can be done here, and that is what is being that's what happening here. So there are, let's say, to learn more about this, you can visit electronics labs, some open access ones, or you can come down to Marvel and we'll be there to show you around, and you can perform experiments. There are a lot of basic beginner experiments. Let's say AC transformers. You must have learned transformers in 12th or something. So that's step up, step down transformers. So how do they work? That can be visualized easily in this. So yeah, please do come down to the lab. We'll be happy to show you guys around this. Thank you.